Chapter 10, Section 3, using chords, so different chord relationships that are inside of circles. Let's take a look at just a very basic corresponding chord. If we have a circle, let's say of that distance and that distance, and I'm going to go ahead and label those AB and CD. And let's say those two chords were corresponding, so they were congruent. Excuse me. So if AD is congruent to BC, then that means that arc AC is also congruent to arc CD. Okay, so the very first one, corresponding chords. If the chords are congruent, then also their intercepting arcs are congruent. So now we're going to look at a perpendicular bisector. And so let's draw us up a circle here. Let's say I have something like this. And so I'll go ahead and label these. Oh, I'm still in red. A, B, C, D, and E. And I'm going to go ahead and show that that's perpendicular as well. And so if I have a perpendicular bisector, that also means that AE and EC are congruent. And it also creates some other relationships. And those relationships are if we have congruent segments of AE and EC, then because it's a perpendicular bisector, oh, I don't want to do that. There we go. Then arc AB is congruent. I want to create a little separation there so it's not the two different arcs. Then arc AB is congruent to arc BC. Now it's important to know that that if those two segments AE and EC are congruent to each other, then that has to go through the diameter, or has to go through the center, excuse me. So the center would be here, and it would be a diameter. If we had a situation like this, where we could have a perpendicular, two chords that are perpendicular, however, you'll notice if it doesn't go through the center, then the one segment's not going to be congruent to the other. You would still have four 90-degree angles technically, but for those arcs to be congruent, it does have to be a diameter that's perpendicular to another chord. So let's get a little practical application here, and let's get us a problem. And so let's say we had something like this. And something like that. And we're going to label it. This is going to be circle A. I don't know why I'm still there. And we'll go B, C, D, E, and F. And so in this situation, we realize that that's through the diameter, and we know these are going to be perpendicular, which means CF and FE, or EF, however you want to look at that, have to be congruent based on our example. And so let's say that CD is going to be 9x, and that DE is going to be 80 minus x. And so if they wanted us to solve for x, then we would just take those two things and set them equal to each other. And so in this case, I would add x to both sides and get 10x equals 80. And then finish that with dividing both sides by 10. X equals 8. Now, they might ask you for x. They might also ask you what the actual arc is. And so you can sub it back into either one of those, either 9 times 8 or 80 minus 8, whichever one you want to do. Either one of them would come up to be 72. So arc CD is equal to arc DE, which is equal to 72 degrees. Again, just depending on what they ask you, if they ask for x or for the value. And one more to go. Okay, this one is interesting. If we, let's say we had a couple of chords. Let's say one right there, and then one right here. Let's get our center in there. And then we have a distance. And remember, distance has to be drawn to a perpendicular. Distance from the center to that chord, and the distance from the center to this chord. I'll get it. There we go. And draw my little perpendicular on there. Let's go ahead and give these some labels while we're at it. We'll call this AB. We'll call this CD. And we'll call this E, F, and G. Okay, so if the chords are equidistant from the center, so let's say that EF is congruent to EG, then chord AB and chord CD are equal because AB and CD would be equal. So AB would be congruent to CD. Again, that's only if EF is congruent to EG. Those distances are the same, which in turn makes arc AB congruent to arc CD. And so that's the equidistant chords theorem. And that's about 9 minutes. That's chapter 10, section 3, using chords.